Welcome, everybody. My name is Corinne Ketterings. I lead the Nutrient Management Spear program here at Cornell University. This is the Applied Research and Extension program in field crops nutrient management for Cornell University, land grant university for the state of New York. We are celebrating our 25th year of existence this year. And we thought one of the ways in which we could do that is by starting our NMSP webinar series, Lunch with the NMSP, with a subtitle, Food for Thought. The target audience for our webinar series is basically anybody interested in what we do here within the program and within the state of New York, but includes also primarily the Certified Crop Advisors organization, Certified Crop Advisors, farmers, students, agency staff, folks, everybody's welcome to join. Because many of you are Certified Crop Advisors, we have also 1 credit nutrient management allocation to the webinar today. And the QR code for that will be at the end of the session here today. We're really happy to report that on top of our already joyful celebration of our 25th year, we also yesterday learned that the College of Agriculture and Life Sciences has selected our team, the Nutrient Management Spear program, as the winner of the CALS Outstanding Accomplishments and Extension Outreach Award. We're really happy to be on the receiving end of this award, and many of you that are participating here today that have worked with us over the past 25 years know that this is a true team award, and not just us here, but with our entire audience that we work with, including the farmers in the state of New York. For those of you less familiar with our program, we have a program flyer that's up on our website. A couple of things I wanted to point out here. Circled in red, it says relevant questions and sound science for agriculture profitability and protection of the environment. That is sort of our mission statement. Our program is here to help improve with the profitability and competitiveness of New York dairy, livestock, and cash grain operations while maximizing environmental protection. We have 6 focal areas in our team: land grant responsibility, soil health and climate resiliency, precision ag, dairy sustainability, on-farm research, and student engagement. The webinar today will specifically focus on the 4th one listed here, dairy sustainability. If you are interested in joining us for more webinars in the future, or interested in learning about the things we publish in terms of research, fact sheets, other articles, the QR code here gets you to a page where you can get access to our website. You could look and join us on LinkedIn. We also have a newsletter that comes out every 2 months that you can sign up for through this link as well. And the QR code gets you to the page that has all of our options to get connected with us. Quick announcement for the 2nd webinar, most likely January 9th, not fully determined yet, and the focus will be on adaptive nitrogen management. But let's go back to today. With this, I want to hand it over to Olivia Godber, who's going to take the lead with her team on dairy sustainability.
Great. Thank you, Corinne. So yeah, I'm Olivia Godber. I'm a research associate with the Nutrient Management Spear program, focusing on the dairy sustainability program. So I've been here for around 5 years now. When we started this out, we had sort of 5 case study farms working with us. So today we want to sort of show you what things we look at in the program and how it's grown over those 5 years. I'm also going to be joined by Juliana and Carolyn, who started out with the NMSP team as undergraduate interns. They're now full-time staff on the Dairy Sustainability Project. And Cameron is also joining us, who is an undergraduate intern and been working with us for around 2 years now. So what are we going to talk about today? We are going to start off just saying a little bit more about what we do as a team. And then we're going to be focusing on the 3 areas that we look at. So we look at nutrients, we look at greenhouse gases, and we look at biodiversity. We really want to turn this into some discussion. So if you have any questions, please put them in the chat, and we will address them at the end. So we're hoping, please get those questions in. If there are questions about any of the assessments we do or how it works, yeah, we're happy to go through that later on. So what is the Dairy Sustainability Program? Well, we want to work directly with farmers across New York, and we want to identify these key performance indicators that are meaningful for farms, that allow them to compare to others and monitor their performance over time, something that is actually going to help them make a difference on their farm, as well as let us work on the research side to see how we can make progress too. The real focus is on that whole farm scale analysis. So if we're thinking about dairy farms, particularly in New York, we have a lot of homegrown feed production. So the cropping side is really important alongside the cows, and we try and capture all of that within our assessments. So, like I've already mentioned, we focus on nutrient mass balances. We look at greenhouse gas emissions, and now we've started working on above ground biodiversity too. And underlying all of that, we try and keep in mind the economics, because if a farm is not making money, they also are not sustainable. So overall, we like to look at the environmental and the economic impact. What are those key performance indicators that can help farms minimize nutrient losses and greenhouse gas emissions, enhance biodiversity, and ensure their economic success? So we've been working with three main tools or assessments. So we have the nutrient mass balance. Currently, about 21% of New York milk is assessed annually in this tool. We also look at those greenhouse gases. We're currently assessing around 16% of New York milk through that tool. And then the biodiversity, looking currently covering about 80,000 acres of New York's dairy farmland. And the key thing about all these tools, which we're going to go into a little more detail, is they allow farms to compare themselves to others. They can identify opportunities for improvement, and we can monitor performance over time. So the first one we're going to look at is the nutrient mass balance, and I'm going to hand over to Juliana to tell you more about that.
There we go. So one of the first assessments again is the nutrient mass balance, NMB for short, where we look at the nitrogen, phosphorus, and potassium. So first we make a boundary around the farm, and then we look at what's going into that system. So things like feed, fertilizer, animals, miscellaneous things like beddings. If you have off-farm heifers where you're not handling manure or the feed, that would also be considered an import when the heifers come back. And then we look at what's going out of that system, which is milk, animals, crops, again, miscellaneous things, maybe manure. And when those off-farm heifers, when they're leaving the farm, those would be considered an export. And then we look at the difference between those two things, and then we put it on a per tillable acre basis, which is more of saying like an efficiency, not efficiency, an environmental number, and then the per hundredweight of milk, which is more of a efficiency number. And then once we have those numbers, we say, okay, we compare it to our feasible balance. So if it's a question of on a per acre basis, are we saying, do I have the land base to recycle this manure? And then when we look at in terms of per hundredweight of milk, again, the efficiency number is a question of, am I efficiently producing that milk? And when we make these reports, we also plot, and if you've doing them for multiple years, we plot them over time to kind of see, if there is any changes you've made on the farm, how that might affected your number. So we do it on both a per acre basis for all three nutrients, and as well as a per hundredweight of milk basis. So again, seeing how maybe if you made any management changes or anything like that, how it might have affected your efficiency and environmental sustainability. And then another way to kind of see those results is our green box figure. So again, we have that blue part, which is the per acre, which is that environmental number. We have the balance on the per hundredweight of milk number to see that efficiency number. And we kind of put them on top of each other, where they have that green box saying that we're meeting both of those feasible balances. And once if you've done this for multiple years, we have multiple data points in those green boxes, in that green box figure, to say how have you changed over time, as well as having those black dots, which are just all the farms we've ever assessed, and to kind of compare to your peers. So, and again, so after we have those numbers, we also give an opportunity table, which is kind of just having some indicators that show like these thresholds that say, if you're kind of passing these numbers, we usually find that farms might struggle to say within that feasible balance. But again, some of these things might be characteristics of a farm. So these are not saying like, oh, you need to fix this. It's more of a talking point of like, oh, maybe look at this. Is this a characteristic of your farm? Or is it like something maybe we can try to work on? Or maybe just really have start a conversation to see what possible ways to become more efficient or more sustainable.
Okay, so just to summarize that, so we have that balance per acre, your environmental indicator, your balance per 100 of weighted milk, the efficiency indicator, and then what we want farms to do is to strive to meet both those indicators. Here you're seeing the opportunity table where we try and identify things that might be making it a little more difficult for you to meet those balances. And things that we've found are key are the amount of feed and fertilizer being imported onto the farm. And animal density is a huge, huge thing that can affect these balances. And then, once we get onto those higher animal densities, manure exports become really important. So looking at these indicators and thinking about that animal density and this question that we have about, there's an expected increased demand for milk in New York. So how are we going to meet that demand, which potentially means higher animal densities? What is that going to potentially do to these balances? And what can farmers do to try and minimize any risks there? So now we're going to jump into some results. And here we have, so the nutrient mass balance began back in 2003. That was when the first farms took part in this assessment. And you can see here on the left, this is the amount of milk that we've run through the assessment at the Nutrient Management SPEAR program over the years. So we're now getting up to over 3 billion pounds of milk per year. Again, you can see the number of acres here that we've covered, and we've seen a pretty big increase over the last few years. And again, we're getting sort of over 200,000 acres going through our assessment each year. So it's really good to see that people are taking part in the assessment. The reason that number's growing is because participants that take part are staying in, and we're getting new participants all the time. And that really helps us to make more be more confident in some of those indicators that we have in the opportunity table. Looking at some of the trends over the time of the farms that we've been working with, we can see that there has been a general increase in animal density. So this is something, that we need to keep an eye on and see what impact that's having. But we've also seen, this steady increase of milk yields both on a per cow basis and on a per acre basis. So that's really good to see. We're making the state as a whole, and for the farms that we have in our database, we're making more milk per cow and per acre. Another thing that we're going to keep coming back to is the percent of homegrown feed and homegrown foragers on the farm. So again, if we look at the percent of homegrown feed and the homegrown foragers, we can see it's been pretty stable for a long time, but over these last few years, we've seen a big increase in the percentages. So in 2024, we had over 70% of feed being grown on the farm and over 95% of the foragers being grown on the farm. So that's really good to see. And we're going to talk a little bit more about why that's so important. Here we're looking at the results for the nutrient mass balance, the nutrients per acre. So on the left here, we're looking at nitrogen, and on the right, we're looking at phosphorus. So if you remember, if you're meeting the feasible limit, it will fall within this blue box. So this is an average for all the data that we have for New York. Each farm would also get if you take part, the farms get one of these that is specific to their farm. But what we can see is that for nitrogen, it's hovering just outside that blue area, so just outside the balance, the feasible balance per acre, but it's been pretty stable over the last few years. We look at phosphorus, this is really good to see. We've seen some substantial improvements and they've been well within that balance per acre for the last few years. And this is bearing in mind that increase we've seen in animal density. So this is a really positive news. We've seen some increases with animal density, but through good management on the farm, we've managed to still bring down this phosphorus balance quite substantially, and the nitrogen one has stayed stable. It hasn't increased. If we look in more detail at that efficiency number, so again, remember that animal density has gone up. But here, if we look at both nitrogen and phosphorus, for the last few years, they've both fallen nicely within that feasible balance and they're both trending down. So that's showing, yes, animal density is going up, but farms have really tight management on both the cropping and the animal side and improving their efficiency of milk production. And this is really great to see, really good efficiency of both of these nutrients. Now we're going back to those green box figures where we look at both of those metrics together. And here we're looking at the data for 2024. So again, focusing on nitrogen on the left and phosphorus on the right. So the black dots are all the farms in New York. The red dots are farms in 2024. And then this big diamond in the middle is the weighted average of the New York farms in this year. So really good, if we start with phosphorus on the right, really good story here. That diamond is right in the middle of the green box area. So this is showing very good management of phosphorus on these farms. They've got a low balance per acre, and they also have really high efficiency. And we actually have 56% of the farms in the green box for phosphorus, and another 17% are meeting that balance, that efficiency balance, the balance per 100 weight of milk. On the left, looking at the nitrogen, this is still, well within that yellow triangle, really good efficiency, hovering just outside that blue box. So the average in 2024 was 109 pounds of nitrogen per acre. Our feasible balance is 105, so it's only just outside, and we still had 27% of the farms falling into that green box. Another 36% were meeting that efficiency indicator. So there we have way over half the farms meeting the nitrogen balance on an efficiency side. So this is really great to see. We know nitrogen is more difficult to handle, and that is something, there's been a lot of work over the years on phosphorus. Nitrogen is now getting a lot more attention, and we are working on it too, trying to find ways that we can bring that balance down. It is very close. We want to see what we can do to help farms get into that green box area. So if you want to take part in the nutrient mass balance, we are always looking for new participants. This QR code will take you to our dairy sustainability page where you can read more about the assessments. And we also have some farmer impact stories on there. If you do take part, we can help you with the data collection and entry. You will then receive an individual report for your farm's balances. You will be able to compare yourself to other New York farms and then get that opportunity table, which opens up that conversation, and we can start looking at areas that might work to make improvements on your farm. It's also, as farms evolve and change over time, we want to make sure that things that we are looking at are still the most important things to be looking at. So this is a continual development. We're constantly learning, and we need farmers' help to help us do that. Okay, we're now going to move on to the greenhouse gas assessment, and I'm going to hand over to Cameron, who's going to give you an introduction to that.
Hi, so yeah, for greenhouse gas assessments, we use Cool Farm tool to assess it, and it looks at a variety of different portions of the farm. It's also taken a whole farm uh, look at the greenhouse gas emissions. So first, we look at our animal feeding and manure. And this is our enteric emissions from the cattle, our manure management using digesters, slurry storages, things like that. Next, we look at soil management. So this is your fertilizer usage, the manure usage, and the way that manure is applied, whether it's spread, daily spread, injected, et cetera, et cetera. Next, we look at our imported products. So the tool accounts for the gases that are needed to produce those products offsite, as well as the gases that are used to bring them onto the farm. And we'd like to mention that crops and animals sold also take a proportion of those emissions with them, as well as the travel emissions with them as well. And lastly, it looks at carbon sequestration, which are your plants that take in CO2 from the air and put it into the soil. And this is mostly affected by your cover crop practices and your tillage practices. So, what are we reporting to the farmers and people that are running these reports? So, we're looking at the total farm emission and emission per pound of fat and protein corrected milk, which gives you your emission intensity. Then we're looking at your emissions from the sources I mentioned earlier, your feed production, enteric emissions, manure management, fuel and energy usage. We also look at grazing management and sequestration. Next, you get an emission by gas. So those are the main three greenhouse gases, your methane, your nitrous oxide, and your carbon dioxide. Then you'll get a figure that shows the progress that you've made so far, and will even detail potential improvements that you can use to keep lowering that greenhouse gas footprint.
Great. So again, that's a brief introduction to the tool and what we look at. I'm now going to go into some of the results again for the assessments that we've made to date. So again, if we look at the amount of milk that's going through, most of the farms that take part in the nutrient mass balance are now taking part in the greenhouse gas assessment as well. If you do take part in both assessments, the additional information we need is only a little bit more. There is a lot of overlap between the two tools. So to date, we're seeing about 1 billion pounds of almost 1 billion pounds of milk going through the assessment per year. And in terms of acres, about 125,000 acres per year. So this is an example of one of the reports that farms would get. Here I'm actually showing the average. These are all the New York dairy farms. So these are New York averages. Each of these black dots is a farm that has participated between 2019 and 2024. And the average emission intensity for all those farms over those years is 0.8 pounds of CO2 equivalents per pound of fat and protein corrected milk. Now, this is good. If we look at these three lines that I have on the graph here, they're all, we have one at 1.13, 1.1, 0.97. These are averages that are in the literature that have been published for North America or the Northeast USA. This one here, the 1.1 is for New York agriculture, but specifically for organic systems. And that 0.8 is falling quite a way below all of these averages. Now, we do need to remember different tools have been used to calculate these, and we may have slightly different production systems, but it's nice to see that New York as a whole is performing really well. Now, it is important to point out, we do see a big range. We have some farms down at this 0.64 down here. We also have some farms higher up at 2.17. So, some farms do have more room for improvement than others. We're learning from these well-performing farms, seeing what they're doing so that we can help these ones with a higher footprint, try and find strategies to help them bring that footprint down. These dots here, if this was for your farm, these would be the points for your farm over the years. These are actually the ones for New York as a whole. What's really nice to see here is we are looking at milk production on this horizontal axis. So this is the amount of fat and protein corrected milk being produced per cow per year. And that has increased over time, but that emission intensity has stayed pretty stable. And that is exactly what we want to see. Farms are producing more milk per cow, but their intensity isn't going up. So they're using the same amount or fewer resources to make that milk. And that is really good to see. And this idea of how we're going to produce more milk without compromising any of these metrics. The farms in our database are showing that, it can be done. But what are they doing? How are they doing that? That's what we want to learn and help spread the word. Here, if we look at the source of emissions, so again, this is for all the farms in our database, we can see about half of the emissions are this big red chunk. So that's enteric fermentation, the emissions coming from the cow herself. And about a quarter of the emissions are coming from feed production. So this is both the homegrown feed and that purchased feed. And then the remaining 25%, most of it is down to manure management. So whether you have open liquid storage, you're a daily spread operation, you have a digester, that will impact this chunk here, this brown chunk, and then the remaining bit is your energy and processing and transport. So another thing that's important to do is we're still trying to understand what impacts greenhouse gases, what farms can do to bring it down. So we have our waterfall figure. What we have here, so again, this is looking at all the New York farms in 2024 as a whole. But what we have is in the center, the 0.78, that's the current practices that are taking place on the farms, and that's what the footprint is. So this is slightly different to the number on the other page because this is looking specifically at 2024. We then look at the farm, or the farms in this case, and look at what best management practices they're already doing on the farm that are helping bring their footprint down. So we have farms doing reduced tillage, we have farms doing cover cropping, we have some farms with digesters and covered manure storages or flare systems. All of those things are helping bring the footprint down. And if they weren't doing those, if no one was doing cover cropping, everyone was at full till, and we had no advanced manure systems, the footprint would be up at 0.87. So farms have already, the practices that are already being done on farms that we are working with, they've got an 11% reduction. Another thing that is really key to look at is this end column, this 1.14. This is if a farm wasn't growing any crops on the farm. So they're feeding exactly the same things to their cows, but they're purchasing it all. And we don't know how that crop is being produced. So we run on the default values that the tools give us. And this is what those emissions would come out at. Okay, it's quite a bit higher than what the farm is achieving, even without any BMPs. And this is showing how the environment that we have in New York and the practices that are pretty standard practices in New York are above average when we're looking at a more national or even global level for feed production. And again, this is worth noting, I said we're going to emphasize homegrown feed production. The more feed you can produce on your farm, the more you can make this difference here. And you also don't have the cost of buying in the feed. But then what else can farms do? So again, this is for New York as a whole, but individual farms get this specific to their farm. If it's a perfect world and there's no compromises to crop yields or milk yields, and a farm went 100% no-till and 100% cover cropped, they were able to put in a digester, or if they're not big enough for a digester, they have a covered manure storage and a flare system, and they feed 3-NOP or Bovaer, which is a feed additive that helps to reduce those enteric emissions from the cow. If they do all of these things and they work to full efficacy, on average in New York, the farms could bring their footprint down to 0.55. And this is what we tend to see, farms coming down between 0.5 and 0.6 if they do everything, or if they put in place all the technologies that are currently available. Now, the industry is talking about getting to net zero. And one thing that we want to do with this is sort of put a little bit of more reality onto things. These are things that farms could do today, and if they worked to full efficacy, this is where we could get to. Yes, things might change in the future. We might get new technologies that are going to help, but we just want to put a number here that is a little more realistic, that farms have something a little more tangible to strive towards. And also for the industry as a whole, it's like, okay, this is what farms can do, and this is where they could get to. Let's focus on these things. So again, we want to acknowledge the progress that farms are making and identify some of those opportunities for improvement. Another thing that's key, that's nice to point out here, so from our 2024 data set, we found that 50% of corn silage acres are being cover cropped, which is helping to achieve this reduction here. And about 50% of acres are also under continuous reduced or no-till. So that means for the entire crop rotation, there is no full tillage taking place. In terms of manure storage as well, because we know that that is an important part of emissions, about 50% of the milk was on farms with an anaerobic digester or a cover and flare system. And about 8% of the milk were on farms that already had a separator in place. So they are potentially good candidates to move forward to a digester or covered system. And then we have about 40% still in open storage systems. Focusing in a little bit more on that homegrown feed, because this is where farms can have a big potential. A lot of people talk about the cow, but on the crop side, there's also big potential for farms and this benefit of growing of homegrown forages. So this is for an example farm. And what we're looking at here on the left is the emission intensity of their crop production on a per ton of dry matter basis. So when we're looking at the whole farm perspective, this number is really important because this is what is being fed to the cows. We look at alfalfa grass acres and the corn silage acres. And then the positive numbers are the emissions that we get from growing that crop. So in the yellow, that's emissions from manure application. The red, which you can see is quite small for this farm, is from synthetic fertilizer application. And then gray is from the fertilizer production. So you get that gray bar just from producing that fertilizer before you've even applied it to your crops. In the negative numbers, we get carbon sequestration. Now, we do need to interpret these numbers with caution. There's a lot of models out there that all give you a different number for this. They all have their pros and cons. This is the one that Cool Farm Tool currently uses. And, you know, these numbers will be different if a different tool was run. But what we're seeing here is this farm, they've got 95 on their alfalfa grass side, 95 pounds of CO2 equivalents per ton of dry matter in emissions. And they're sequestering, so potentially removing 300 pounds into the soil. So if we take the difference between those, we get a negative number, over 200, negative 200 pounds of carbon are being stored in the ground for every ton of dry matter that's being produced. And again, we also get a negative number, 150 minus 170. The difference between those again is minus 20. So this is saying that this farm is actually a net sink and storing more carbon in the soil than they are emitting in emissions from producing that crop. So this is, again, if you think about, you know, there's certain parts of the greenhouse gas footprint that is really difficult for a farmer to do anything about. So some of the things on the enteric side, or if they can't change their manure management system. So by emphasizing the importance of this homegrown forage production and the fact they can sort of offset some of those other emissions on their farm is really key. We also give those numbers on a per acre basis. So if you're looking just at the cropping side, people like to look on a per acre basis, but because we're looking at the whole farm, this per ton of dry matter becomes really important. And again, so things that are contributing to this sequestration is this cover cropping of corn silage acres and going to reduced or no-till. So again, the same as you saw before, here is the link to our dairy sustainability page. You can see the input sheets there, find out more about how to get involved, what it involves, and our contact details if you want to find out more. Okay, so next up is our biodiversity assessment, and now I'm going to hand over to Carolyn to talk to you about that. Could you switch the slide? Sorry. Is this work?
So the reason we're looking at biodiversity in New York is because, as many of you know, we have a lot of forest in New York, we have a lot of natural lands around New York, and a lot of them are either integrated with our agricultural systems or around our agricultural systems. So because of that, a lot of farms have been asking us, what are we doing about biodiversity? It seems like there's a lot of interest in it from the industry side. And additionally, because no one else, it seems, is really doing this in the Northeast as well as in the whole of the US, there could be a potential market advantage for this down the road, whether that be some kind of maybe premium or holding a market, a nature-focused market that you might not have had before. So the problem with measuring biodiversity is that it's pretty hard to measure every single species on a farm, especially when you have farms the size of New York dairy farms, where you have hundreds or thousands of acres as well as hundreds or thousands of cattle. So there's a lot of barriers to data collection for biodiversity in New York. And what we're working on now is trying to reduce those barriers to measuring biodiversity. So the first thing we're doing is, instead of going out and counting every single species on a farm, we're trying to estimate biodiversity through indicators of biodiversity. So data points that we might be able to collect either through things we already collect for the nutrient mass balance, or things we might have to go and collect ourselves. Either way, data points that serve as kind of a proxy or estimation of biodiversity. It'll hopefully save farms time, save us time, and provide an accurate measure of biodiversity. But we want to make sure those indicators are reasonable to measure for farms. So our current focus is trying to get feedback on certain indicators of biodiversity. And in addition to that second point, they're developing locally relevant indicators. Of course, nature changes across even the Northeast, so something that might work as an indicator of biodiversity in, say, Massachusetts or down south is probably not going to directly translate to the state of biodiversity in New York. So for this point, we're going to need to work with farmers, ecologists, and extension to figure out what indicators of biodiversity we need to be measuring. In addition to that kind of, in addition to that kind of indicator measurement, we need to develop efficient ways to accurately estimate areas. So things like, for indicators of biodiversity, you could use forest area or water stream length. Farms don't always have that information on hand and ready to go. So we're trying to make that measurement a little bit more efficient through satellite imaging. And then, of course, easy integration into other sustainability assessments to help lower those barriers. So ideally, we would be able to use a lot of information from the nutrient mass balance and greenhouse gas assessments. We're working on figuring out if there are any indicators or data points that we can use from those assessments that also translate to biodiversity. And so far, it seems like there are several things we can use from both of those assessments. So as we're working on these indicators, we're looking for a lot of feedback from farmers or anyone that wants to be involved in such a biodiversity scheme. So if you're interested, please help us. We're looking for any kind of feedback. If you want to look over the list of indicators, it would be such a great help to us in developing this further.
Okay, so yes, we are very actively trying to get people to get involved in this. We really want feedback, whether you are a farmer, a planner, anyone that's involved in New York agriculture and might have a way that we can make this easier for everyone. But we see a huge opportunity for New York in this area. Okay, so what are our next steps? We're collecting a lot of information. We're working with a lot of farms. We want to grow how many farms we're working with. But we also have this big question that people keep asking us is like, okay, we've got this expected 20 to 30% increase in milk demand for New York. How are we going to meet it? What is that going to do? So that's a big focus for us at the moment, looking at those greenhouse gas emissions, the nutrient balances, and the biodiversity, trying to bring it all together and see what key performance indicators are most relevant, both at the farm level and the state level, and what tools we should be using to do that. So we talked about 3 tools today, 2 more specifically, the nutrient mass balance and the cool farm tool for greenhouse gases. That doesn't mean we're only going to use those tools. We're part of what we want to do as in this program is assess all the tools that are available that might be relevant to New York and seeing which ones give us the best information, are user-friendly, and can be relied upon. So yeah, it's really important. You know, we showed great improvement in the phosphorus balances. We're seeing, you know, stability in the nitrogen, but it'd be really great to bring those nitrogen balances down. Nitrogen is also a big part of greenhouse gas emissions. So how do those 2 things relate as well? Are there any practices that we could suggest to farmers that might help improve both of those indicators? So once more, we'd love to get you to get involved. If you're a farmer, you work in extension, or you know someone who might be interested in finding out more, if you work for a company, we would love to discuss with you how you could get involved with this and what it all entails. We're also very welcome to any of you that do already participate to receive feedback on how things are done and what you would like to see us doing in the future. And then I'll just point out our confidentiality because I know that is something that's very important to everyone and it's important to us too. Anyone who provides data to us, it does not get shared outside of the dairy sustainability team without your permission. Even if we want to share with colleagues who are not a member of the dairy sustainability team, they need your permission to do that. This is so, we understand that it can be sensitive information, and we want to protect that. So again, a big thank you to everyone who has worked with us so far. This has grown from sort of 5 farms in the first year I was working here to over 100 now. So it's great to see that. We want it to keep growing. And we really appreciate all the support that we get from the farmers, but also their planners and nutritionists who do put a lot of effort into helping us get good data to run these assessments and find out new things. So with that, we're gonna open up for questions. And yeah, if you want to put them in the chat and Karina and I can help moderate them.